All right, welcome everybody to day one of VulnCon. Appreciate you all being here for this inaugural event. The title of this talk is CVE is the worst vulnerability framework except for all the others. So that should be interesting. We have with us today Ben Edwards and Sander Vinberg are your presenters. Couple of announcements to make. Session surveys are available in the conference mobile app or via QR codes found around the venue table 10. So please do fill those out and or hit us up on Discord or both, whatever. Your feedback really matters to us, especially as a new event. We're learning a lot and we're going to continue to improve. So thanks for filling those in. Cell phones, as a courtesy, obviously, turn off any electronic devices that are going to make unpleasant sounds. Please note that sessions are live streamed for our remote participants. So if you have a question, make sure that you either say that question into the mic or nobody will hear you. Let's see, and we're good there. And all right, with that, I will kick off to our presenters.
Thanks, everybody, for coming this afternoon. Here, I'm going to pull this out right now. I appreciate you all coming to this talk. We named it kind of controversially to fill this room, and I think we succeeded. So first of all, a quick disclaimer. Due to the way the tech industry is, Sandra and I no longer work for the employers that we did this research for. Some of this was done in personal capacity. Some of it was done for some work previously. So we'll tell you a little bit about the history in a little bit, but we do not represent our current employers at this talk. Disclaimer 2, there are some people here at this conference, because I've met them already, who were there when this stuff was written about, when this stuff was created, when the schemas were made. So we are seeing what we see in the data, and we're seeing what we can gather from the internet and limited conversations with people. So we may not get things right, okay? So you're not allowed to get mad at me. And then as a third disclaimer, we are also not really going to be critical. So if you see work up here that you are a fan of, know that we are not criticizing it. We're not telling you it's bad. We are just making observations about how things could be different, especially because a lot of decisions that were made about frameworks and how they're constructed were made in the past in a context with input that we may not have been party to. So we don't want to cast aspersions. We don't want to say, this is terrible, and I'm really going to try not to say that. Okay, to the title of the talk, you may recognize this as a famous Churchill quote. And I think this encapsulates things that we'll get to in the conclusions, but it really is about kind of democracy is the best form of government, except for all the others, meaning everybody, worst government except for all the others, thank you. Everybody complains about CVE, right? We have lots of complaints about it. We're going to detail why people have these complaints about it and what the stories behind some of those complaints are. But it is the thing that we can rally around. It is the thing that we can center on. There was another Churchill quote that's, the best argument against democracy is 5 minutes with the average voter. I thought about the best argument against CVE is 5 minutes with the average vuln researcher. But it turns out that's not an actual Churchill quote. It's made up. So we couldn't use that. We went with this one. Okay, so my question really here is, do we often take, and I see analysis, I'm a data analyst, I'm a data scientist who works in security. Do we take CVEs and the associated frameworks kind of for granted when we do analysis? And I'm talking about things like EPSS, which I think is great. I've been a part of it. You guys should all use it and go see it. If you want to walk out and go to the EPSS talk that's happening right now, I won't be too insulted. There's other efforts like predicting the volume of vulnerabilities. If you're on LinkedIn as much as I am, there's just tons of graphics and stuff. Patrick, I had to throw your beach towel in there. And the idea is we take this data analysis as like, oh, there's good schema, there's good data. Let's see what we can figure out about what the landscape is. And so I want to ask the question is like, are we doing this right? So here's a little outline of what we're going to talk about and how we're going to investigate kind of that question. We're going to talk about history, both of the talk and the data and what we see in there. We're going to look at long trends. We're going to talk about deliberate changes that have happened to these frameworks that affect those data. We're going to talk about kind of changes that are occurred without large announcements that you may not notice. We're going to talk about how a lot of what we're doing, a lot of what we see in CVEs and associated frameworks are subjective assessments, and reasonable people can differ about these things and in fact do. Some of those subjective assessments come from different incentives from those people and organizations. We're also going to talk about malicious things. I don't think there's really been an attack, unless somebody can correct me, but we have some templates for them. So, and then we're going to tell you all about what we should do going forward. A little history of this talk. The original report was done when I worked at Scientia, and it was a sponsored report by F5. Sandra and I put it together. We presented it RSAC for a sponsored session. You should go read it. It's really good. We evolved that for a workshop that happened in Wales this last fall. And then we have evolved it more for this. So there's a lot more new content. So if you were at any of those other talks, stick around because we've got new stuff. But I just wanted to give you some context for where this work is coming from.
If I could interject, the original report that we wrote is called The Evolving CVE Landscape. There is going to be a lot of analysis in that report that we just don't have time to discuss here. So if you find yourself and you just need a lot more of what we're going to do tonight, if you go to f5.com/labs, search Evolving CVE Landscape, or just search CVE, you will probably find that report. So highly recommend it. It is F5 Labs property, and it was work that we did when I was at F5 Labs. And there's a lot of extra stuff in there.
Yeah. All right, so let's talk about the history of CVEs. I think this is personally fascinating. And I wish if there's a journalist or historian somewhere in the audience who would ever like to go do kind of primary document research to write a book about this, I would totally read it. So back in 1999, a quarter century ago, Dave Mann and Steve Christie present a framework, and they say we should categorize CVEs. We should have a common way to talk about them. 9 months later, an initial list is published of about 321. I think it's fun that it's, the idea from gestation to birth was about 9 months. And then in 2000, really two lists emerged. There was some concern that having MITRE, who was really a corporation, be in control of all the CVEs was not great. And so NIST started this thing that was a precursor to NVD called the ICAT. And it was the Internet
Collection of Attack Tooling.
There you go. So it was focused
like that.
Yeah, it was focused on not just like vulnerabilities, but exploits. So that ran for a while. It was also strange. There's like cat memes on the ICAT website if you look at archive.org. And to think about a government website with cat memes on it it blows my mind today. But you can go back and look. So in 2001, NIST actually kind of defunded ICAT. They were like, we don't think this is useful. We're not going to keep doing it. The SANS Institute stepped up. Grad students kept assessing CVEs and kept it running for several years until DHS in 2004 really funded it, called it NVD, professionalized it a little bit. In that time, Red Hat had become a partner. They were not a CNA officially yet, but they were a partner who could request CVEs. In 2005, that process became sort of official, and there was a small group of organizations that were CNAs. You can see some other stuff that maybe you're familiar with. CVSS2 is adopted. CWE start getting used in 2007. CPEs come out a year later, so we have more alphabet soup. Things get revived. Recently, 2016, end of 2016, early 2017, the CVE process or CNA process really opens up, and just about everybody can be a certified numbering authority. And you just go through an application process, and we'll talk about what that means later. And then most recently, CVE JSON record has been formatted, updated to 5. And so that process has continued to evolve. I think that's sort of interesting here is that this thing that happened 23 years ago where NIST defunds ICAT and SANS keeps it running, is that maybe happening again? I don't know. I've been to like 4 talks, and I think all 4 of them have mentioned this problem. I am just going to steal my friend Jay's post on LinkedIn about how it does seem that NVD is falling behind on these things. So, maybe history doesn't repeat, but it rhymes. And so I don't know if that's what's happening now. But now that I've given you kind of a brief history, Sandra is going to talk about the data.
Yeah, and there's kind of a what I can consider like the foundational plot for this study looks like this. And what you see here, this is the weekly publication rate of CVEs in NVD for the last 18 years. So from 2005 up to the present. And what we've done here is we have sort of applied many different lines of best fit using a type of analysis called segmented model analysis. And this will essentially identify breakpoints where a line of best fit no longer fits future data. And we've actually, this is the second version of this. We originally first produced this. It had 5 breakpoints applying to data through 2022. We recently updated it through the end of 2023, and now we actually have 7 breakpoints. And there's a lot going on here. This plot, the reason I consider it foundational is that this actually has sort of clues to many of the topics we're going to be talking about throughout the rest of the talk. One thing that is really important to understand is these kind of outliers right here at the end of 2014. We're going to be talking about those quite a bit. Another thing to just recognize is that since the beginning of 2017, we've been in this phase where we are essentially in a period of continuous exponential growth in the number of CVEs. Probably not a huge surprise to you all. There's a lot of other work, including the Vuln Forecast work by Aaron Leverett and Matilda Road that has also demonstrated that CVEs are just sort of accelerating. But I think that that's an important kind of ground truth to understand. All of the challenges that we're going to talk about today, all the challenges with NVD that we're all aware of, are happening in the context of more and more CVEs being published every month. What this means is by April 2026, we're going to be looking at a median publication rate of almost 800 vulns, and the upper bound is looking at 1,850 vulns per month, right? So this is, at least the way that we see it, this model tells us this problem is only going to accelerate. Now, the other thing that I really want to emphasize here is look at what happens at the end of 2016, the beginning of 2017, right? So we were actually in a relatively steady state between 50 and 150 vulns per week, right? And then at the end of 2016, all of a sudden we jumped up, and that was when this period of exponential growth happened. Now think back to what Ben just said in the history. 2 things happened at the end of 2016. We had the republication of a new CWE view, so new guidance in terms of how to assign weaknesses to vulnerabilities. And that was also when the CNA program really started, and we started to have many, many more actors assigning identifiers to new vulnerabilities. And so at the same time that we have this kind of structural change in how we're using the framework, we also can see that change be mirrored in terms of what the data is actually telling us. We also
2016? No. Oh, the 2021? No, that's a little later. I mean, that's fall. I don't know. I don't have a good explanation for why there is a breakpoint there, other than that's what the modeling tells me it should be. But I mean, that's, 9 months after the first cases were February, March that year. I remember because I was RSA. So maybe that's, I mean, who knows?
We also wanted to try to get a sense of publication timing. Like when do organizations and CNAs publish new vulns? And the short answer is that there's not a huge, or rather there is a bit of a pattern here, but it's not incredibly useful. So what you see here is a breakdown by days of the week and months of the year, and when you are most likely to have a new vuln be published. And Mondays in December happen to sort of constitute the midpoint. Essentially, what this is telling us is that, yeah, it's a little more likely that you're going to see a new vuln on a Wednesday in April than some of the other times. So we don't really know what's going on there. What we do know quite definitively is that we don't get a lot of new CVEs on weekends, which is good news, I think, for all of us. Yes.
So this is actually, and we probably should have stated this, we are going to use NVD generally. So this data was cut off, I think February 15th, so before the kind of NVD thing. So this represents the NVD publication date. So it is probably part of reflection of process, right? Where they get certain number of CVEs, they process during working hours, they come out, which is why we don't get a lot. But they do get published on Saturdays and Sundays, just not as much as other things. Yeah.
We also wanted to look for kind of a seasonality, right? So moving away from days of the week, we want to see, are there Do we get them in the summer? Do we get them in the winter, et cetera? And essentially what this is telling us is over the last 18 years or so, not a lot of seasonal trending. One important thing to note here is that the color shading showing density here is normalized for each year. That's why you see a really sort of high density thing, 25% there, and the same kind of amount of density is only 11% there, right? So normalized per year. Short version is not a lot of seasonality in terms of vulnerability timing. Our advice is don't try to game the system and predict when the new CVEs are going to come out. Okay, so moving on to the question of new vendors entering the system. This is a plot of weekly publications, right? Weekly publications, thank you, that are being published by brand new vendors. So a vendor being assigned a CVE for the first time. You can see we did the exact same kind of segmented model analysis. You can see that though many of these breakpoints are different, again, at the end of 2016 and the beginning of 2017, a little bit more spread out than what we saw in the first one. There's this kind of dramatic uptick, and now all of a sudden we're seeing way more CNAs participating in the system. And since that breakpoint, we've been once again in a period of kind of steady exponential growth of new vendors publishing CVEs for the first time. Hold on a sec, please. So that's one view. I also think it's really important to contrast that with this view, and this is a plot of the proportion of new CVEs coming out that are being published by a new vendor, right? So on the one hand, this is telling us more and more vendors coming into the system every single week. But this is actually telling us that in terms of the proportion of new vulns, they're not publishing faster than the old players are publishing, right? So the way that I interpret these two plots together is on the one hand, we're seeing sort of expansion at the edges of this system, but that expansion is going slower than the increase in density at the core. So the really, really high frequency vendors are publishing new vulns faster than the new players are coming in. And this is kind of maybe the best way to summarize this up. What you see here is a plot between the number of CVEs that individual vendors have published and how many different vendors fit into that bucket, right? So by the time you get down to one, every single point here represents a unique vendor. Whereas as you go up, these dots contain a larger and larger number of vendors. So by the time you get to the top there, nearly 60% of vendors that have published a CVE have only ever published one. What this means is that those 10 vendors down at the bottom there have collectively published more than twice as many vulns as the bottom 60%. And so I think that's a really good way to encapsulate the relationship between what I think of as the center of this system, which is the vendors that are kind of publishing constantly, versus this very large population who have only ever published one CVE in the entire time of working. Okay, so moving to the question of CPE. For the most part, CVEs are very narrowly focused. So we see 90% of CVEs affect one vendor, 74 affect just one product, 49% affect one version. But there are a few outliers here, and they're pretty interesting, and they tell us a little bit about how this system works, right? So in terms of many different manufacturers, we have 2017 15361. This affects 35 distinct Chromebook manufacturers that all had a faulty trusted platform module chip that is responsible for kind of like firmware level encryption. And then at the level of products, there was a flaw in, so let's see this. This was in any virtual machine running on an Intel chip. So it applies to 1,500 distinct products. If you go and look at this on NVD, there are, I think, about 780 distinct configurations. It's really, really interesting because the vendors range from Intel. There's some F5 products in there. I think there's some Oracle products in there. So it's really, really wide-ranging stuff, but not as wide-ranging as this one. And this is essentially just an artifact of the way that Cisco does this. Cisco puts their extremely granular versions, and they put that into kind of every CVE that they publish. The upshot is that 2016 1409 affects nearly 5,000 distinct Cisco versions. How many actual products are, I don't really know, but the point here is that these are some examples of this system not really treating all CVEs equally in the sense of what we come to expect when we like I said, 90% affect just one vendor. We need to be cognizant that they're not all going to fall into that pattern. And I think you had a really good observation about Log4j in this context, right?
So when we first looked at this, I expected something like Log4j to be one of the ones that has the most unique CPE strings, whether it's version, vendor, whatever, and it's not. And part of the reason is we think about CPEs as being directly related to the actual vuln, but it is somebody at NVD, somebody at a CNA who goes through and says, I have to create this CPE string, so I'm going to. And so like that Cisco one, somebody at Cisco, I believe that's a Cisco CNA CVE, went through and said, I will enumerate all the versions, I will generate all the strings, and I will upload them to the CPE dictionary, right? There are probably vulns out there, Log4j was one of them, where whoever the analyst was like, okay, this affects everything. I can't enumerate everything, right? And so there is this like, there's a human factor here where people are creating these, and this takes effort and work, and we can't do it perfectly every time.
Yeah. So thus far, essentially what we've been talking about is the first signs that Ben and I encountered when we were going through this data that maybe not everything was working the way that we were assuming that it was. And from there, we started to observe a lot of changes in the framework itself that in turn affected how we were consuming that data. And so I think discussing just the number of CNAs, this is probably a good place to start. And Ben's actually going to unpack this plot in a lot more detail later on in the talk. For now, really suffice to say that this just kind of illustrates how many new CNAs have come into the system. And the first time we really see that explosion, again, is right around the end of 2016. So the end of 2016, beginning of 2017 was when the CNA program in particular kind of started to take on the form that we would recognize today as the way that CNAs work. You'll also note that these are shaded by the weekly average CVE publication rate for that CNA. Orange values represent really, really prolific CNAs. Blue values represent really, really sparse CNAs. And you can see that for the most part, with the exception of a couple really interesting CNAs over on the right, many of the older ones have published many, many more CVEs over lifetime of their CNA membership versus many of these newer players that are not yet quite so prolific. Okay, so also on the subject of changing frameworks, obviously CVSS has changed quite a lot over the last 15, 20 years. So what you see on the top here is just a plot of the proportion of CVEs that are being assigned a given CVSS score. So we can see that for the bulk of the time, it's just been version 2. There was a period where it was version 2 and 3.0. 3.1 kind of eclipsed 3.0, and then you can see right around the end of 22, version 2 kind of drops off, and now we're in this phase where it's new CVEs now are only being assigned a CVSS score of version 3.1. On the bottom here, what you see is a plot of the distribution of that kind of base severity over time for CVSSv2 in the middle, CVSS version 3 on the bottom. And that was kind of one of the first ways that we started to realize this, which is the relationship between the CVSS version that we're using and what it means for the average severity. I think this is absolutely fascinating because I like to talk to lots of people that have been in security for a long time, the salty old folks. And it's always really interesting to hear them talk about what it was like to respond to vulns 20 years ago, way before I ever got into this field. And what we see here is that actually, if we had just stuck with CVSS version 2 the entire time, what we're seeing is the average severity is going down. Something funny?
Well, yeah, I mean,
did I
no, you're good. You're good.
Okay. Whereas, it's not that I think that version 3 is not better. I think it's significantly better, but it will produce on average a higher score to the level that the average is now a high instead of a medium. So again, it's not that vulns are actually getting worse. It's that we came up with a new system, and that new system will regularly produce a more severe score, right? So this is a really, really good example of the way that the changing frameworks is also changing the way that we're dealing with the CVE system as a whole. And no discussion of changing frameworks would be complete without talking about OWASP. And this plot, which is arguably Ben's crowning achievement, we all like this plot very much. This shows the way that the different categories within OWASP have changed rank over multiple years, over the 6 different generations that we've had the OWASP top 10. Couple things to note here. The dotted lines represent time periods when a given category has fallen out of the top 10 only to resurface later. I think probably the best example is the cryptographic failures dropping off the map after 2010 and then coming up in 2021 in an amazing comeback into second place. Another thing to note is that these categories are getting reorganized all the time. And the best example of that is cross-site scripting, which was doing pretty well until 2013, kind of lost the plot in 2017, but then got folded into injection, right? So cross-site scripting is now considered an injection attack as of 2021. So the one takeaway after the most obvious takeaway that there's been a lot of change in the ranking is that the contents of these categories are also changing. So the changing in the obvious changes in the rank also need to be understood in the context of the significantly less obvious changes in what are we even comparing here when we rank it. And to kind of tell you a little bit more what we mean by that is that this is just a count of the number of distinct CWEs or weaknesses within each OWASP category, right? And so you can see there was a period in kind of 2007 to 2017 where by all accounts, it looks like OWASP was extremely parsimonious with their CWEs, and there were not that many different kind of weaknesses within each category. And then the most recent one that we got in 2021, it has sort of exploded. And now there are a total of more than 200 CVEs or CWEs weaknesses in the latest top 10. If we look at it in terms of how many CVEs are included in each one of these, that's what this plot is showing us here. Again, really, really important to recognize that these different categories, A1 through A10, are themselves changing, right? So A2 in 2021 is not the same as A2 in what was it? 2018, 2017 was the previous one. So the point is that, and this is, again, not to criticize OWASP. I think OWASP is fantastic. It is an amazing resource for all of us, but it is not a sort of objective, immutable source of data. It is essentially just there to help us understand what to do next. It doesn't sort of function as a historical document. Okay, and then so essentially everything we just talked about was about either the data itself changing or intentional and kind of public changes to how we're using the framework. But now we're actually going to start talking about the little sneaky changes that maybe didn't get so publicly just discussed.
Right. So as Sanders said, changes in OWASP, changes in CVSS, the SIGs make a big deal. That's good. We should say this data is changing, not that anybody ever listens. So I wanted to investigate like how individual CVEs have changed. Now, the great thing is NVD has maintained a change log, and it goes back. So every time a field in the NVD JSON changes, they will log it. It has an API. You can go hit it. There are more changes than there are CVEs by a long shot. So it plotted them like over the course, the data that changed in the horizontal. And then the vertical is the total number of CVEs that had something changed about them. And you'll notice there are dates. These are individual days. This is probably weeks. There are individual weeks where we're changing nearly 10,000 different CVEs. Something about them is changing in the changelog. We've sized them by the total number of changes, because sometimes you're going to change a CVE and you're going to change the references, or you're going to change the description or something else. So we're going to talk about what fields get actually changed. But as you can see, there's a lot of stuff gets changed. But the NVD that you saw a year ago is probably different than the one you're seeing today if you go and just pull down the whole thing. Okay. So what are these changes? Thank you. I'm going to fall on my face. Thankfully, they are, for the most part, in my opinion, not fully material. So, for example, we get a lot of changes to references, and particularly references getting added. So as people do examinations, they find more out about the vulnerability. NVD is going to add those references to their entry. Reference type, this is interesting, going from like advisories. So they may say, oh, initially this was like a proof of concept. Now we know that this is just like, it just tests the version. So there may be changes to the referencing type. And then of course they're removing references a lot. There's like dead links, things that maybe aren't totally relevant. Those get removed a lot. Interestingly, things like CVSS do get changed occasionally. So if you're thinking about severity, it gets changed sometimes, but not too much. Some of the removals are interesting. So usually they will remove a CNA vector and leave the NVD one, or remove the NVD one if they think it was incorrect. So there are a number of changes that take place kind of across the board. But this was heartening in the sense that it's not going to change my strategy too much. So one of the other main sources of data that we have is not just NVD, but MITRE, of course, has maintained their own CVE list. We talked about that in the history. MITRE does not have a change log. And when I started looking at some of the MITRE data, I noticed some weird things that occurred that didn't make sense historically. So in particular, Sander talked about this chart. Each dot here is a CNA. And we know that the kind of open CNA process got started back here in late 2016, early 2017. A lot of these older CNAs were part of the process that occurred in 2005. So things like, or places like CERT, Microsoft, Red Hat, they became early CNAs. They were partners. But it's weirdly enough, if you look at the MITRE data, there are things like this CVE, which was published, actually NVD thinks it was published in 2002. The original MITRE date says it was published in 2002. Their record says it was published in 2006, and it was assigned to Red Hat. So if you'll remember, the official CNA process didn't get started till 2005. So how is Red Hat the assigning CNA 3 years after the birth of really this process, and before the CNA program existed? There are about 27,000 CVEs that existed kind of in this time period. And some of them that existed prior to 2005, 94 of them. So what's going on here? So I dug in a ton, and I went to try to find some interesting posts. I recommend you go read these two things. This is about becoming a CNA and kind of some ancient history from both Microsoft and Red Hat. Red Hat is now like a root CNA. Go read those. They're kind of references. I recommend them quite a bit. Your water bottle's leaking. That sucks. So like I said, MITRE doesn't have a change log. But some enterprising student at Purdue made one years ago. This, I have no idea the provenance of this, but Purdue, what they do is they go scrape the MITRE website every day, and they look for fields that's changed. I'm pretty sure they're parsing the HTML to figure out what's changing. They don't give a ton of detail. So for example, they only say, oh, there was a change in references. And this link just links to the MITRE page, not CVE.org, but the MITRE page. But if you look through the different files, we can see here that on March of 2019, something big happened. So most of these things are kilobytes, but in March, 14 megabytes of changes occurred on the MITRE website. So I dug in a little bit on archive.org, and I found what happened is in March of 2019, they added the CNA to a bunch of these vulnerabilities. And in fact, they retroactively added CNAs to Microsoft, Red Hat. If those CNAs should be the owner of those vulnerabilities, they got added. But if you weren't aware or were dealing with data from pre-2019, you have no idea who the assigning CNA was. And then I think also more to the point, for a long period of time, these CVEs didn't belong to Red Hat. They belonged to MITRE. They were the assigning organization. So this kind of got changed under our feet without anybody saying anything. Now, I know what a lot of you in this room are thinking of is that we have a solution to this. There's new technology out. And of course, if we fix this, we put all CVEs on the blockchain. You think I'm joking, but this is essentially what MITRE did. The current CVE 5 list exists on Git. It's all version controlled. They do releases every day. Git is a Merkle tree, which is the same thing that most blockchain is built on. This is actually the CVE schema commit log between the release candidate 2 and release candidate 3. I think this is overkill for a database, but at least we now have a record of changes for MITRE, for CVE MITRE. And I got to make a joke. Okay, so these are changes that occur. We can now track them. We have a change log. This is not a framework change, but these are like tweaks to little data. So now I also want to talk about sometimes what happens is the framework gets changed a little bit, but we don't really tell anything. So I'm doing some research on the KEV currently. This is CISA's known exploited vulnerabilities catalog. KEV publishes when the vulnerability got added to the KEV, and then, of course, when federal agencies have to fix that vulnerability by. Interestingly enough, there's a bunch of vulnerabilities that have due by dates years before they got added to the KEV. And there's actually a simple explanation. What happened is they had the authority, CISA had the authority to direct federal agencies to patch vulnerabilities 2 years before, nearly 2 years before the KEV was created. So when they created the KEV, they were like, oh, we've already had these executive directives to fix these things. We'll just add these. And so what happens is these ancient ones, if you try to do data analysis, say, you need to fix this before we told you about it. Interestingly enough, when we try to combine the KEV with other data sources, we also get kind of these strange things because the data sources don't exactly mesh. So this is KEVs that occur before publication. There are a number of times when something gets added to the KEV and it is not yet a published CVE, which is kind of in contravening with the rules for adding things to the KEV. Most of these are called what's reserved but public, which means the CNA has reserved the ID, they've released information about it, it's public, but it hasn't percolated up to the root CNA, which is MITRE for the most part, or other sources. But sometimes this is worse than that. So, for example, Cisco published this CVE on October 16th, 2023. CISA adds it to the KEV list a week later, although they get the release date differently than what Cisco thinks the release date is. And they say you have 4 days to fix it. It does not actually get added to MITRE until a day later. So this was on the KEV before MITRE published it and before NVD published it. And interestingly enough, if you go look at the CVE metadata, I'm sorry, this is probably real blurry. It was reserved 2 days after it was published. Or 2 days, I'm sorry, it was reserved, 2 days after it was published. So this is my way of saying, like, when we try to combine data sources, when we try to do stuff like this, we're going to come up with, is it 2 years? Oh, yeah. So this is even weirder than, in my opinion. But, oh, yeah. Okay. You caught me. This is another reserved but public one. But there you go. But, I mean, first published in 2023. So Cisco doesn't even know what it's doing. All right. See, this is what happens when I try to make changes yesterday. I had another vuln. We should have stuck with the Google one. All right. This is you.
Yes, it is. Okay. So now we're going to talk about times where I think the phrase that Ben used earlier was reasonable minds can differ, right? So just disagreement about the characteristics of vulnerabilities. And this is one of my favorite plots of the whole study. This is about disagreements between the CNA and NVD in terms of CVSS score or severity, right? So the diagonal line from upper left to lower right, that's the consensus view, right? So for instance, the most frequently observed thing here is where NVD thought this is a medium, the CNA also thought it was a medium, everyone's happy, right? So anything above and to the right represents a scenario where NVD scored something with a lower severity. And anything bottom left is where the CNA scored something with a lower severity. Now, you will note that as the severity goes up, it is more likely that the CNA is going to try to kind of sandbag that rating and keep the severity down, right? So when we're at mediums, you see that the CNA going for lower is actually less frequent than NVD going for a lower score. Once we get up to something that the NVD calls a high, it is actually more likely that the CNA is going to call it a medium. By the time we get to crits, it is way more likely that the CNA is going to be like, oh, that's not a crit, that's a high, right? So essentially what I'm saying is as the vulnerabilities kind of go up in terms of their the stakes, we are more likely to see this kind of disagreement in the sense that the CNA is going to be saying it's not really as bad as it looks because we have all this extra information. Whoops, 2 slides. There we go. So we also found that about 5% of CVEs have multiple CWEs assigned to them. And this is a good example. This is actually just a CVE that I happen to be looking at when we built this stock, and I noticed that it had two. And you can see one is assigned by NIST, one is assigned by Citrix, and they're right next to each other. They're adjacent, right? So this is a relatively minor disagreement. If you've ever heard us speak on this topic before, I erroneously claimed that CVEs are not supposed to have multiple CWEs. We were mistaken. That's totally fine. But it's still a problem if you are trying to do an analysis and look for sort of frequency of CWEs across CVEs and that sort of thing. So it's not the sort of procedural screw up that I thought it was when we first found this, but it is still potentially a problem in terms of data analysis. We also wanted to see kind of how did the assignment of CWEs evolve over time. And I'm going to show you two plots here. So if this feels like an eye chart, don't sweat it. What this is showing is the 15 most frequently assigned CWEs over the last 20 or so years. And the proportion in any given quarter of publication, the proportion of new CVEs that were assigned that kind of weakness. So on the upper left, you can see cross-site scripting had a period kind of 2012 to 2015, where it was totally the 800-pound gorilla of weaknesses, right? About half of vulns during that period were cross-site scripting. And then various ones kind of have other kinds of scores. For the most part, with the exception of out-of-bounds write and out-of-bounds read, most of them have been declining in proportion as we get closer to the present. And if we actually expand this analysis to every single CWE out there, this is what you get. And so I realize this plot's crazy, so bear with me here. Every column represents a unique weakness or CWE. Every row represents a quarter in time. And the density of the shading is, again, it's the proportion of new CVEs in that quarter that were assigned that weakness type. And again, so cross-site scripting is over on the far right. That is the furthest right one, followed by SQL injection, path traversal, code injection, and a couple others, and the out-of-bounds read and write. And essentially what this is telling us is that there have been periods in the past where either SQL injection or cross-site scripting were the kind of predominant type of weakness. And right around the time that cross-site scripting ceases to be the predominant kind of weakness, we also see this kind of explosion in terms of the diversity of weaknesses being assigned to CVEs. You'll also notice that the time that this happens is right around the end of 2016, the exact same time that we had the expansion of the CNA program, and we have the publication of the new CWE view, which in this case, that's probably a lot more significant than the CNAs. So at the same time that we got new guidance on how to assign weaknesses, the way that we started doing that in practice completely changed. What this means is if you're doing an analysis of CWEs and their incidence within CVEs, you're essentially looking at two different time periods, two different histories that you should probably be analyzing quite differently. Okay, Ben, tell us about incentives.
Okay, so there's disagreements with CWEs or CVSS. What might be some of the reasons for that? So some of you might remember this kerfluffle with curl that happened. I don't know if he's there, if he's here, if Daniel's here, but this was an interesting thing that happened where somebody filed a vulnerability. They filed it with HackerOne. HackerOne says, yep, great, looks like a vulnerability to us. We'll give you a CVE ID. It goes through the process. MVD scores it a 9.8. And so curl gets wind of this and says, wait a second, this is a bug. This is not a vulnerability. He writes a blog post. He really hates it. He pushes back, and he is right that this is not nearly as severe as a 9.8, and there's other problems with it. It's actually, they get it changed to 3.3. This is one of the CVSS changes that happens in the changelog. But it does show you that a software developer working on an open source project has different incentives when assigning a CVE than maybe a consumer of curl might. So if I use curl in my development pipeline and I'm worried about vulnerabilities, maybe I care about this. When he's a developer and he says, I don't know, I don't think it's that bad. On the other end of the spectrum where developers might be kind of more inclined, the Linux kernel is now a CNA, and they have made noise that says every bug is potentially a vulnerability. And so we are going to assign a CVE to every bug we fix. So I don't know if this is actually happening, but my good friend, Jerry Gamblin, who I just stole his chart from, he's here. He said I could, has indicated that a large percentage of vulns so far in 2024 are from the Linux kernel. They seem to be making good on their promise that they are going to assign CVEs for just about everything. So if any of you have worked in vulnerability prioritization and you are already overwhelmed with the number of CVEs you're getting, this is maybe a bad thing. So it does beg this question of like, when is a bug a vulnerability? This is something we should think hard about. But it is like two ends of the spectrum. So the other, and we kind of got at this with the CVSS scores, we wanted to look at when a vulnerability is assigned by the CNA versus when it was assigned by MITRE or not the vendor. Whether they have a different CVSS score. So what this is the difference in CVSS score, that's the vertical axis, versus like, what the average score was. And everything below that dotted line means that the vendor, when they're in charge, score it lower than when somebody else does. So Microsoft vulnerabilities, when they are a CNA, are lower than Microsoft vulnerabilities when they are not the CNA. Say Mattermost is really bad. I don't know what they do actually. Google, Tenable, and whether it's 3 or 4, there are some vendors who score things lower when they're the CNA than not. So if it's MITRE, if it's HackerOne, if it's ZDI, I'm thinking of GitHub, some of the other big ones that do lots of things besides just their own stuff. I don't know. This could be correct, right? So the vendor may be more right. I'm not saying vendors are sandbagging stuff. They may be correct. Maybe it's the other people who are being alarmist. But it is something that is curious. All right. I'm going to talk about how vulnerability frameworks might be subject to attack. I don't think these are fully realized attacks, but I think they give us a framework for how we might see them in the future. So thinking about that Linux kernel vuln, it turns out, again, history doesn't repeat itself, but it rhymes. Sandra pointed this out. In 2014, there was a period of a few weeks where we were getting, instead of like 150, like hundreds and hundreds of vulns. Okay. If you dig into what they are, there are many of them that have almost exactly the same description. And what it is this Android app is bad at SSL. And for example, this one is my favorite because Grandma's Grotto is a gluten-free recipe app. All it does is present you gluten-free recipes, but it does so, and it also makes HTTPS connections, and it doesn't handle SSL correctly. So it gets a CVE. When I first presented this, I was like, oh, isn't this weird? And my good friend Art was like, yeah, I know what happened there. So essentially what happened is back in 2014, Will Dorman finds a bunch of Android apps that are bad at TLS. They attempt to assign a CVE for all of them, and MITRE says, no, please stop. Because at that time, there were only a few CNAs, and MITRE was the only root CNA, and so they really couldn't handle it. I quoted you guys, and hopefully that's fine, but this is basically the full story. I'm not going to read to you off the slide. But I think it's important, it's interesting to see that there's like 19,000 pending CVEs that are like this, and that depending on how you view the CVE process, these are correct, right? This is a new vendor. It's a different software application. It has a bug, but is that bug its own CVE, or is that, should it be kind of a single one?
And also almost 20,000 CVEs, that's like almost 10% of the entire total body.
Yeah.
So do we need to inflate our total body of vulns by 10% to capture all these SSL problems? Like, I don't know. That's a tough question.
Yeah. And this is a good place to transition because you're talking about the next thing anyway.
Brilliant. Okay, cool. So I think probably everyone in the room here probably heard about this last year, right in the beginning of December. CISA was forced to remove a CVE from the KEV list. And right around the same time, NVD also marked it as rejected. And I think that it's really, really valuable to kind of unpack everything that happened here, because it was sort of a combination of missteps and errors along the way. And we think that this is this is not malicious, but we think it was a potential avenue for malicious disinformation and kind of poisoning the CVE framework. So what happened here was there was a security researcher who published 4 CVEs, including this one. So it's 2022-28958. The researcher published, as part of this thing, a proof of concept exploit, like you do. And then a few weeks later, there were some malware operators that were running a network of the MuBot malware, which is a variant of Mirai. And they found this researcher's POC. They grabbed the POC, they modified it to serve their objectives, and then they started using it in actual attack campaigns. And then over the month of August, a threat intelligence vendor detected that traffic in their own sensors, and they published a notice about it. And they said, hey, we're seeing MuBot use this new vulnerability. This is exploitation in the wild. This represents a really big problem. So then, of course, CISA does what they're supposed to do. Is they said, okay, we're seeing exploitation in the wild. We know about this vulnerability. We're going to add it to the CAB. Everybody go patch your stuff, right? And so this is September 2022. In December 2022, so just a couple months later, Jacob Baines from VulnCheck does a really deep dive into this vulnerability. And essentially, he pulls it apart from every possible angle you could expect. And the summary of his write-up, and his write-up is absolutely brilliant. You should go check it out. He said, it is a broken exploit for a vulnerability that never existed in the first place, right? And so a year later, wait, that still says 22. Oh, so the rejection was 22? I thought the rejection 2023. So nearly a year later, like 51 weeks later, NVD reads Jacob Baines' post and says, okay, this seems like a good analysis to us, and they take it down from NVD. And then just a couple of days later, CISA removes it from the KEV list. Is no longer an urgent priority for patching. And I'm not going to go through the proof that the vuln didn't exist, but this is just a screenshot from the threat intelligence vendor talking about the exploits. This is just on the exploit level. And you'll note that the post is going to an asset get cfg.php, and then they said that it's targeting a vulnerability in the SharePort.php component. And that was kind of the first signal that we had that I don't think this exploit is going to work. It actually turns out that there's a bunch of URL encoding errors in here. Like, there are so many problems with this exploit, on top of the fact that the function, the set function within PHP never even worked the way that the author thought it did. So again, this wasn't actually a malicious attack. This was just a sort of a comedy of errors. But we have examples now of both attackers and defenders incorporating information and making decisions on it and recommending decisions and behavior to other people without actually checking their facts. And I am not the greatest hacker out there. So if I found that problem with that exploit, I think a lot of other people, better hackers than me, could be expected to identify that kind of problem. Now, again, this was not a malicious thing, but if I wanted to poison the NVD, and if I wanted to make a lot of people waste a lot of time, this would actually be a really good example. For instance, using an LLM to create both a vuln that doesn't exist and an exploit that doesn't even need to work. If you were to flood a system with that kind of information, you would waste a lot of people's cycles. Okay, so at this point, I think we have demonstrated many different angles where the data is not, where we can't take CVE data at face value. So now what do we do, right? So first, let's kind of like talk about all these things. So we have demonstrated, I think, irregularities on all these different levels. So we have public changes to the data. We have these kind of covert changes where maybe they were hoping we wouldn't notice. There are subjective disagreements among working professionals. We have working professionals with many different incentives who are all trying to get something different out of this system. And then there is at least the potential for people with malicious intent to actually game this system to their own advantage. I think that we probably made it pretty clear that a lot of these irregularities are not obvious. We didn't go into this study looking for the irregularities. We went in that it was actually kind of a big mess, right? So the first thing that I really want to emphasize is that if you're going to use CVE data to make strategic conclusions, do really weird things. But I think it also kind of gets to a couple more fundamental questions. And one way to phrase it is to think about what a CVE really is. I think of a CVE is not the absence of a vulnerability. Absence of a CVE is a 0 day, right? A CVE is a way to communicate and mutually communicate about a vulnerability. This framework. And I think we've shown there are a lot of purposes and there are a lot of different needs, right? So we actually went back to the CVE organization's mission statement, and they said that the mission of the CVE program is to identify, define, and catalog publicly disclosed cybersecurity vulnerabilities. I would argue they're doing great on the identity, right? We all have these unique identifiers. They're doing really, really well on the definition. The cataloging, I'm not sure that they're actually doing that well. So what does this mean for the future? Well, I would argue that right now, trying to use the CVE system for this kind of analysis is like trying to ask the fuel gauge in your car how much fuel you had last week or how much fuel you're going to have next week. That's not what that system was made for. Right now, we have an alerting system that we're trying to use as an archive, and I think that's a really big problem. So if we want CVE to work for this kind of analysis, we need to design it to support this kind of analysis. And some of the suggestions we have: make the data more easily accessible, make it more easily machine readable, be cognizant of the contents of the data, changes to the data, document these things over time, solicit input from the stakeholders that you actually want to work with. There are a lot of data scientists that will be extremely vocal. In fact, this room is full of people who will be extremely vocal about how we should design the system. We just have to talk and listen to one another. And we also just need to make this system and the process behind it a little bit more publicly accessible. When I try to tell my friends about this conference that I'm going to, nobody has any idea what I'm talking about, because again, we're in a niche of a niche of a niche, right? So actually, this is kind of a good opportunity to highlight the work of Patrick Garrity, who has done a lot of work in the last couple of years, making sure that more people understand this framework and how it all works. So that's what we got. We didn't really solve any problems. I think we just raised problems, but I hope this has been useful. I hope you guys learned something. Thanks very much.